Welcome to this episode. I'm Captain Stromberg, and today we're going to show you how to make a program that's going to work so that you can tell your robot to go a number of centimeters rather than trying to do either rotations or degrees of rotation. And there's a lot of advantages to using centimeters. First of all, it's pretty simple to make a program that does this, and secondly, it also helps you a lot when you're trying to program your robot to do your course. It's really easy to take out a ruler, measure, okay, I need my robot to go 13 centimeters. So you tell it to go to 13 centimeters. If you're using either rotations of the wheels or degrees of rotation, that's not very easy, and you're going to have to kind of guess how far do you want it to go, run the robot, and it either did go how far you wanted to or you didn't. So then you got to guess again, and you waste a lot of time by using trial and error to figure out how far to make your robot to go. And by using centimeters, it makes it much easier and saves a lot of your time. So there's a little bit of work that we got to do in order to make this Myblock. First, we need to figure out the conversion that we need to use. And so we're going to get a tank move block, and we're going to have it go on for degrees of rotations. And initially it's set up for 360 degrees, which is one full rotation. Well, we want to actually make it go 10 rotations, so that's 3,600 degrees. And we're going to just use the default speed of 50 here, and that's fine. You might get a little bit different result at different speeds, so if you're using a consistent speed with your robot, try to use that when you're doing this conversion. It should all work out the same, but just in case, be consistent. So I've got this little program set up, and I'm going to have my robot go for 3,600 degrees of rotation, and we're going to go measure how far the robot actually goes. Alright, something I didn't cover earlier is why do we want to use centimeters instead of inches? And there's a lot of reasons. Number one, a centimeter is smaller, an inch is larger. Also, centimeters divide by 10 and you get millimeters, so you have a very accurate way to subdivide that. Inches, they like to divide in halves, quarters, eighths, sixteenths, which is harder to use when you're subdividing it. So we're going to use centimeters, and then we're going to be able to do, like, if we wanted to go 3.1 centimeters, that's 3 centimeters, 1 millimeter. So it's easy to use. Alright, so I have my robot, and I have a starting line, and I've got a tape measure, so we're going to run the program and see how far it goes. Alright, and we're going to take a look at this. And it appears to have gone 173.5 centimeters. So we're going to run this a few more times and make sure our results are consistent. And I'm going to do that without the camera because I already know it is. And then we're going to go back and see how we can use this information to make a Myblock. Alright, now that we know that the robot goes 173.5 centimeters in 3,600 degrees of rotation, we need to figure out what to do with that information. And what we're going to need is a calculator. So we're going to grab our calculator, and we're going to take 3,600 degrees of rotation, divide that by 173.5. And we get 20.749. We can safely round this off to 20.75. And the reason we had this go 3,600 rotations, or 10 degrees of rotation, is 10 rotations of the wheel. And that gives us a nice long distance, so that when we're using this conversion factor on shorter distances, it'll be very accurate. So 20.75 is the number we need to know. So we no longer need this, but what we are going to need is a Myblock. And it's real simple, just math Myblock, and we're going to multiply. The A value is going to be how many centimeters we need. And so that'll be for the Myblock. And then here is going to be 20.75. And now all we got to do is turn this into a Myblock. So we'll go to Myblock Builder. And again, I always have my blocks start with MB for Myblock, and then have a description of what it is that's a relatively short name. So it says centimeters to degrees of rotation. And it's always good to have a description so that if you don't remember what it is, you can figure it out. So converts centimeters to degrees of rotation. And so now we're going to need a few things. One, we should make a picture that's representative of what this Myblock does, and it deals with the motors, so we're going to use this little motor symbol here. And we need two parameters. So the first parameter is going to be an input, and we're going to input centimeters. And we want a parameter icon. And anytime we use centimeters, we want to use a consistent graphic. That way when you're connecting the lines in your program, you know that centimeters go to centimeters. So we're going to pick a nice centimeter one. Then we're going to go to our second one, and this is going to be degrees of rotation. And this is an output value. So this is going to come out of the math block, and the parameter of icon. And in the motor block, for degrees of rotation, they use this symbol here. So to be consistent with what the program already uses, I'm going to use this symbol for that. Now, whenever you're making a Myblock, you want to double check everything before you actually finish the Myblock, because you can't come back in and edit these settings. So we have a picture. We've got small typos, so we fixed that. We try and be really exact. Input is degrees of the input is centimeters, input number, and it's got the right icon, and the output is degrees of rotation number. All right, so we can go ahead and finish. And then the centimeters go in here, and this gives us our degrees of rotation. So let's go ahead and now try this Myblock and see how it works. So we're going to take a new program, and we're going to need our Myblock first of all. So there it is. And then we're going to need a move block. And we're going to have this go 10 centimeters. And this is going to be on for degrees. And here you see that symbol is the same as over here. So that's our cue that we're going to connect those two right there. And then we're going to have it stop when it finishes the program. So I'm going to go ahead and see how this works and see if the robot moves a consistent value. Alright, so now we're going to go ahead and test our program. We told it to go 10 centimeters, so we're going to go ahead and run the program and see what it actually does. Alright, so now if we look very carefully, it went just a little bit past 10 centimeters. So we're going to move it back. We're going to run it again. And again, it moved just a little bit past 10 centimeters. And there's actually a really good reason for that. And that's because the robot has a little bit of inertia. And once it sees that it's gone the correct amount of distance, it goes ahead and it tells it to stop. But the robot's still moving before the brakes are applied. So there's a little bit of overrun. And there's an easy way to fix that. So the easy way to fix that is to go into the Myblock, and we're going to, instead of using just the multiply, we're going to go to an advanced Myblock. And we had A times B, A times B, and now what we're going to do is we're going to subtract just a small correction for that little bit that it overshoots. Now it's overshooting by about a half a centimeter, which we figured out that it's 20.75 for 1 centimeter. So we're just going to go ahead and call it about 10. And so we're going to go ahead and subtract 10 degrees of rotation from our program, and that should give us a more consistent stopping. So we've changed the Myblock. It's 8 times B minus 10, and that should help us stop right where we want it to. All right, now we're going to try the running this again with the correction added to the Myblock and see what happens. And that's exactly on 10 centimeters. Now we're going to quickly change the program. Instead of going 10 centimeters, we're going to have it go 20 centimeters. And everything should just keep on working, and it should stop at 20. Here we go. And right at 20 centimeters. It doesn't look like it because the camera's not straight on it, but if the camera gets straight on it, it's right there at 20 centimeters. So that's how you'd use this. That's a quick little program. It actually takes a little bit of time. Most of that is running your robot. But once you figure all this out, it makes it a lot easier when you're making your programs to have your robot go the right distance. Hope you enjoyed this video. I'm Captain Stromberg, and good luck